Workers repeatedly dip suspended wicks into vats of molten tallow, each immersion adding a thin layer that gradually builds candles through systematic repetition of the dipping cycle. Metal molds filled with liquid tallow surround prepared wicks, cooling, transforming the fluid into solid candles, displaying the uniform cylindrical form impossible through hand dipping alone. Finished candles emerge from cooling racks, displaying smooth surfaces and consistent dimensions. Systematic production creating the illumination products that lit homes and workplaces before gas and electric lighting transformed society. Trimmed and polished candles receive packaging for distribution, the complete manufacturing process supplying the essential lighting that extended productive hours beyond daylight's natural limits. This is just part of the systematic process transforming tallow into candles inside this 1830s steam-powered factory. Before we continue with the complete process, if you could leave a like and subscribe to the channel, it would really help this project continue bringing historical industrial content. Thank you for your attention. Now back to the video. Animal tallow arrives at the candle factory in barrels, rendered fat from cattle and sheep, providing the primary material for candle production throughout the early industrial period. This tallow, a byproduct of meat processing, finds valuable application in candle making, where its properties of melting at moderate temperatures and solidifying into firm structures suit the requirements for functional illumination products. Workers unload tallow barrels, organizing inventory by quality grade, as different tallow sources yield materials with varying characteristics affecting finished candle appearance and burning properties. The highest quality tallows produce candles with better color, reduced smoke and more pleasant odor during burning, commanding premium prices in markets, serving wealthier customers demanding superior illumination products. Lower grade tallows serve economy candle production, acceptable for industrial and working class household use, despite inferior burning characteristics and stronger odors during combustion. The tallow undergoes melting in large steam-heated kettles, transforming the solid fat into liquid, suitable for purification and subsequent candle-forming operations. Steam coils within the kettles provide controlled heating that melts tallow without the risk of overheating or burning that would degrade quality and create unpleasant odors in finished candles. Workers monitor melting carefully, maintaining temperatures that keep tallow fluid without excessive heat that would darken the material or alter its chemical properties. The melted tallow displays the characteristic off-white to yellowish color of animal fat, with quality variations visible in the liquid's clarity and shade. Purification processes improve tallow quality by removing impurities, blood residues, and other contaminants that would affect candle appearance and burning characteristics. Workers may treat melted tallow with acids or alkalis that precipitate impurities, enabling removal through settling or filtering operations. Some manufacturers employ bleaching treatments using chemical agents that lighten tallow color, producing whiter candles that command higher prices in quality-conscious markets. The purification intensity varies with intended candle grade, with fine candles receiving extensive treatment, while economy products undergo minimal processing beyond basic melting and settling. Steam power enables sustained heating during purification, maintaining temperatures necessary for chemical treatments while providing mechanical energy for stirring and agitation equipment that improves processing efficiency. The wick preparation represents essential candle component manufacturing, as the cotton or linen threads forming wicks must be treated and arranged properly to ensure even burning throughout candle use. Workers cut wick material to lengths appropriate for intended candle sizes, with longer wicks needed for tall candles, while shorter pieces suit small illumination products. The wicks may undergo chemical treatment or coating that improves burning characteristics, reducing smoking and promoting steady flame, rather than guttering or excessive flickering during use. Some wick preparation includes braiding multiple threads together, creating structures that curl as they burn and position the flame optimally for clean combustion. The prepared wicks are organized by size and type, ready for incorporation into candles through either dipping or molding processes. If you could leave a like and subscribe, it would help keep this channel active with quality historical content. Thank you for your attention. Now continuing with the process. The dipping method represents traditional candle making adapted to industrial scale. with workers repeatedly immersing suspended wicks into vats of molten tallow until sufficient layers accumulate to create finished candles. Dipping frames hold multiple wicks suspended vertically, enabling workers to produce many candles simultaneously through each dipping cycle. The frames are lowered into tallow vats, the wicks absorbing liquid that solidifies as they are withdrawn and exposed to cooler air. Each dipping adds a thin layer of tallow, with the candles growing gradually thicker through repeated immersions, spaced to allow partial cooling between dips. This systematic repetition continues until candles reach desired diameter, with workers controlling final size by adjusting the number of dipping cycles performed. The dipped candles display characteristic tapered forms, slightly thicker at bases compared to tops due to the accumulation pattern inherent in the dipping process. The dipping operation requires careful timing, as insufficient cooling between dips causes new layers to melt previously deposited tallow, while excessive delays reduce production efficiency. Experienced workers develop skills in recognizing optimal dipping rhythm, balancing quality against productivity to maximize output while maintaining acceptable candle characteristics. The dipping room maintains moderate temperatures that prevent excessive tallow cooling in vats, while enabling adequate solidification on suspended candles between immersion cycles. Molded candle production represents more modern manufacturing technology, employed increasingly during the 1830s, using metal molds that create uniform cylindrical candles with superior consistency compared to hand-dipped products. These molds, typically made from tin or pewter, contain cylindrical cavities with wick holders positioned centrally to maintain proper wick placement during tallow solidification. Workers prepare molds by inserting wicks through bottom openings and securing them under tension that keeps the wick straight and centered throughout the mold's length. The prepared molds are arranged in racks or frames, enabling efficient handling during filling and cooling operations. Workers pour molten tallow into the molds, filling each cavity completely to produce candles of uniform length and diameter determined by mold dimensions. The pouring requires care to prevent air bubble formation and ensure complete filling around the wick, as voids would create weak points or irregular surfaces in finished candles. As tallow cools and contracts, workers may add additional material to compensate for shrinkage, maintaining proper fill levels that produce candles matching specified dimensions. The molds remain stationary during cooling, with heat dissipating through the metal walls as tallow solidifies from outside inward around the central wick. The molding method produces candles with consistent dimensions and smooth cylindrical surfaces impossible to achieve reliably through dipping operations. These molded candles command premium prices in markets valuing uniformity and appearance. Though the capital investment in molds and longer production cycles compared to dipping make molded candles more expensive to manufacture. The 1830s represent a transitional period when both methods operate simultaneously, with manufacturers selecting approaches based on market requirements, available capital, and production volumes. The candles undergo cooling whether produced through dipping or molding, with adequate solidification necessary before handling to prevent deformation or surface damage. Dipped candles cool naturally while hanging on their frames, the suspended orientation preventing distortion as tallow solidifies. Molded candles remain in their metal molds during initial cooling, with the metal conducting heat away efficiently and enabling relatively rapid solidification compared to dipped candles cooling in open air. Workers monitor cooling progress, recognizing completion through visual assessment and gentle testing that confirms adequate firmness for safe handling and subsequent processing. Once adequately cooled, candles are removed from molds or cut free from dipping frames, revealing the finished products ready for trimming and final preparation. Molded candles typically require warming of molds to facilitate release, with gentle heating loosening the tallow's grip on metal surfaces without softening the candles excessively. Workers tap or shake molds to dislodge candles, catching them carefully to prevent damage to the smooth surfaces that represent major advantages of molded production. Trimming operations cut candle bases to uniform lengths, removing excess material and creating flat bottoms that enable stable standing when candles are placed in holders during use. Workers employ sharp knives or mechanical cutters to sever candles precisely, measuring carefully to achieve specified lengths while minimizing waste from trimmings that will be remelted for subsequent production batches. The trimmed candles display professional appearance with even lengths across production lots. Important quality characteristics for commercial sales where consistency affects customer satisfaction and enables efficient packaging. Some candle production includes polishing operations that smooth surfaces and enhance appearance, particularly for premium products serving quality-conscious markets. Workers rub candles with soft cloths, the mechanical action warming tallow surfaces slightly and smoothing minor irregularities while creating subtle luster that improves visual appeal. This hand finishing represents skilled labor that adds value, justifying premium pricing for fine candles, competing in markets where appearance influences purchasing decisions. Quality inspection examines candles for straightness, surface defects, proper wick positioning and dimensional consistency affecting functionality and market acceptance. Inspectors check that wicks run centrally through candle lengths, as off-center wicks cause uneven burning and rapid consumption of tallow on one side, while leaving excessive material on the opposite. Surface examination identifies cracks, air bubbles, or color variations indicating production problems requiring process adjustments. Candles displaying significant defects are separated for remelting, recovering the valuable tallow, rather than selling inferior products that would damage manufacturer reputation. Approved candles receive bundling and packaging, protecting them during storage and distribution, while displaying manufacturer information and candle specifications. Workers tie candles into bundles using paper or fabric wrapping, creating packages of standard quantities, facilitating inventory management and retail sales. The packaging may include labeling indicating candle size, quality grade, and manufacturer identity. Important information helping customers select appropriate products for their lighting needs and budgets. The candle industry serves essential lighting markets. Before gas and electric illumination will gradually replace candle use over subsequent decades. The 1830s represent peak candle demand, as growing urban populations and industrial operations require illumination extending productive hours beyond daylight, while gas lighting remains expensive infrastructure limited to wealthy households and commercial establishments in major cities. The factory's production capacity supplies lighting needs across economic classes, with premium candles serving wealthy customers, while economy grades provide affordable illumination for working-class households and industrial facilities. Inside steam-powered candle factories like this, systematic production transforms animal tallow into illumination products through processes combining traditional craft methods with emerging industrial techniques. The machinery continues operating, prepared to receive new tallow shipments and repeat the melting, dipping, moulding and finishing cycles, creating the candles that enable activity after darkness falls. Steam power provides heat for tallow melting and mechanical energy for equipment where applicable. Though much candle production retains significant hand labor, reflecting the transitional character of 1830s manufacturing, where industrialization proceeds unevenly across different operations. Workers combine traditional candle-making skills with factory organization, maintaining quality while achieving production volumes, serving markets far beyond the capacity of small-scale craft producers operating individually. Did you know that the shift from tallow to paraffin wax candles in later decades would dramatically improve candle quality? But the 1830s tallow candles represented the peak of traditional animal fat illumination technology. If you enjoyed learning about industrial candle production from the 1830s, please subscribe to the channel, leave a like, and comment about what surprised you most. Your support helps us continue bringing historical industrial content. Thank you for watching. See you in the next video.